Howdy. This is Mr. Potter. In our previous lesson, we talked about how to create our initials. But one of the things that we noticed is that we ended up with a very long program. And we mentioned that computers are very good at repeating tasks over and over again. As a matter of fact, it's so good that oftentimes we'll just have to tell it how many times to repeat a task, and it'll do it for us. So that's what we're going to be doing today. We're going to be taking the exact same program that we had before, but we're going to be tweaking it so it doesn't take nearly as much space. In other words, anything that's repeated more than 2 times, we're going to try and condense in a way that's going to be much more effective for us. So I want to talk about these instances where we have Barry moving. Here Barry is moving 6 times. And so what we can do is we can actually replace this with 2 lines of code. One line of code is the computer being told that, hey, you're going to need to repeat this task. And we do that using a for loop. So this idea of a loop has 3 parts. The first part of my for loop is my starting off point. I'm starting to count at I being 1. I is an integer, so I'm counting by whole numbers. Starting my loop control variable I at 1. My second part is a test. I want to keep going until I reach a certain number. So in other words, as long as I is less than or equal to 6, we're going to keep repeating this. Now, I want Barry to move 6 times. So if I'm starting at 1, that would be 1, 2, 3, 4, 5, 6. So I want this test to keep going if I'm less than 6 or if I'm equal to 6. And I want it to keep going by incrementing I by 1. Now there's a way to increment that's very easy in Java, and that's the idea of using the plus operator. And that just tells I to add 1 to itself. So I starts as 1, we add to it, and it becomes 2. We add to it, and it becomes 3. We add to it, and it becomes 4. We add to it, and it becomes 5. We add to it, and it becomes 6. And then once it's 6, that's the last time. If we add to it again, we're going to get 7, and this is no longer going to be a true inequality. And so it's going to stop repeating. Now this is going to repeat the next line that shows up underneath it. That's this Barry.move, which means I don't need any of these Barry.moves, which means we've taken this program and we've reduced it by 4 lines, because we replaced 6 Barry.move statements to 1 Barry.move statement a repeating loop. So if I run this program, it does exactly the same thing, but my program is shorter. And that really is the idea, that I'm telling the computer, instead of explicitly do these 6 things, I'm telling it to do this one thing 6 times. It's more efficient, it takes less memory in the source code, it takes up less memory in the computer. So I want to do that anytime I'm doing something more than twice. Because if I'm only doing it twice, I'm replacing 2 lines with 2 lines. I want to do this when I'm doing anything more than twice. So looking at what we've got, this is the first time we moved, and then we turned twice. So there's no saving here for turning twice. And then we tell Barry to move 6 more steps. So that looks like a place we can save time. So I'm going to put a for loop in here, and I get 1 I less than or equal to 6 I plus plus. And that's going to tell Barry to move. And that means all of these other Barry.moves are completely extra. Then I tell Barry to move, to turn twice. That's only 2, so I'm not going to get any savings. But then I tell Barry to move 6 more times. So again, I'm going to put in a loop, and I get 1 I less than or equal to 6 I plus plus. And I want to repeat the Barry.move statement and get rid of all of these other Barry.moves. Turning twice, no savings of time, but again, Barry's moving 6 times. So this is something where I could save space with a loop. And I gets 1 I less than or equal to 6 I plus plus. And we're going to do Barry.move and get rid of all of those. And that was what we did for Barry. We had Barry move 6 and then turn twice. Move 6 and then turn twice. Move 6 and then turn twice, and then move 6 one final time. So if I run this program, this should do exactly the same as before. I should have that exact same O shape. And I do. So now I need to do the same thing with Billy, because I want Billy to do these things over as well. So I've got Billy.turn, 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 Billy.turn. This is a candidate for replacing with a loop. So I'm going to put in my for statement, int I gets 1, I less than or equal to 6, I plus plus, and Billy.turn. And that means I can get rid of all of these other Billy.turns. Notice, by the way the sprint moved to the left, that meant that my line numbering went under 100 lines. So in other words, this program was 100 lines long, more than 100 lines long, and I'd be able to make the program shorter by using these loops. So what else is a candidate for shortening? I've got 6 Billy.moves, which I can replace with another loop. So 4 int I gets 1, I less than or equal to 6, I plus plus, and Billy.move, and get rid of these other ones. I've got 2 Billy.turns, so that's not a candidate. It's not going to save me any lines of space, because replacing one of them with a loop that only counts twice still only is 2 lines of code. But I've got Billy.move 6 times here, so I can replace that. So 4 int I gets 1, I less than or equal to 6, I plus plus, and Billy.move, that gets rid of those. I'm turning twice, that's not saving any space, and then this is the top of the C, so I'm moving 6 times. So I'm going to have 4 int I gets 1, I less than or equal to 6, I plus plus, and Billy.move, and get rid of the rest of these. So we went from having a program that was over 100 lines to a program that's now at about 82 lines. And if I run this program, I end up with the exact same output. And that's really the power of a for loop. The idea is that if I know I'm going to have to repeat a task, and if I'm going to have to repeat it more than twice, it's more effective for me to use some type of loop to tell it, hey, do it this number of times. So it's going to be much more effective for me to work with repeated tasks using a for loop. The other thing that I'd like to talk about is these move methods that we've written. I mean, we're telling Barry to move 6 steps. We're telling Barry to move 6 steps. We're telling Barry to move 6 steps. We're telling Billy to move 6 steps. So we have a lot of situations where we're kind of telling a particular bug to step forward a particular number of times, what might be really helpful for us is if we were to write some kind of shortcut way to say, hey, this bug, let's move him this many times. And so what I'm going to do is, below all of this code, after this public static void main, I'm going to write another method. So I'm going to do public void and move it. And what this is going to allow me to do is, if I'm given a particular bug, which we'll call B, and some integer value, let's call it num moves. What we'll do is we'll set this up so that a particular bug will move a particular number of times. And so this will be kind of a shortcut way of telling a bug to move a certain number of times, rather than us explicitly having to do it every single time. And this is going to be another space-saving technique. So what we're going to do is we're going to say for int I gets 1, I is less than num moves I plus plus. And what we're going to do is we're going to tell whatever bug we're talking about, whether it's Barry or whether it's Billy, whatever bug we get, we're going to tell that particular bug, which I've nicknamed B, to move. And so what that means is, instead of this place right here where I'm telling Billy to move 6 times, I could just say move it. And I want Billy to move 6 times. And so what happens is this move it says, hey, B is really Billy. We're going to have B be his nickname, and we're going to tell Billy to move num moves times. Num move is 6. So we're going to tell Billy to move 6 times. And that means that every time I have this loop where I'm telling Billy to move 6 times, all I really have to do is say that that's move it. Billy and 6. And so that means this line right here, which we'll copy, will replace this Billy dot move. And this is actually where Barry is moving. So we'll have that replace Barry dot move. So we'll copy that and we'll paste it, and we'll paste it, and we'll paste it. This idea of using a subroutine or a method method or a function to replace code that is repeated often is a real important part of computer science. The idea that I am solving a problem by breaking it up into smaller parts, but what I'm doing is this little task right here. Given a particular bug B and a number of moves, tells that bug to move that many times. And every time I've been telling my bug to move 6 times, it's moving it 6 times. So I've got this nice little pattern here. So let's go ahead and run this. And I need to have one little mistake here. This needs to be a static. Just like it's public static void main up here. It's static, and I'll explain what static means later in the course. So this needs to be public static void move it. So let's go ahead and run that real quick. That should have taken care of all the mistakes. Process completed. And notice that I've got the O and the C. So Billy's doing the O, and we've got this nice O. Barry's doing the C, and he's got this nice C. And just calling upon this move it method, telling a particular bug B to move a particular number of steps, saves a whole bunch of time. So this is one of our idea where we can take this huge program, and just by putting in the loops makes it shorter, but putting in this move it command, this little subroutine, this function or procedure, allows me to make it even shorter. Now there's lots of stuff that we could do. For example, I could kind of do the same thing with turn. Just have turn it be a method. And that might not be a bad thing for you to write as a static turn it method. Something that will tell a bug B to turn a certain number of times. And that way, instead of having all of these Barry.turn, Barry.turns, I could just say, hey, Barry, turn 2 times. Hey, Billy, turn 6 times. So that sounds like a wonderful thing I can let y'all work on. But I do appreciate you listening. This is Mr. Potter. Thank you for watching. Have a great day.